is we're going to get a few background information. First, as shown here, what we're going to want to do is we're not going to do, of course, wanting to do curve turns. What we want to do is box turns. Some flight planners have the option to do curve turns. I know Leachy does. That's why I mention it. The reason for this being that with the curve turns, you're introducing less heading change, and if you have these box turns, you're doing more of a heading change. Then it improves the IMU output. Gives a better heading information, more accurate information. We have a few other ways of doing this as well, but so with the actual flight planning, we're talking about stuff like swath width, flying height, line spacing, all these parameters that you need to look at when you're laying out your mission. When you're actually going to lay out your mission, you can go to fly your project site. This gets us, into flight planning, an autopilot system. The way we have it now essentially allow you to, of course, use any flight planning application. The sensor is doing its own thing, so you're not having to set up anything there. The flight planning you're able to use pretty much whatever you want, whatever tools you want, whatever allows you to do plan your flights effectively, I should say. And it should work fine as long as you keep these parameters that we're using. You'll be fine. Now I'm going to demonstrate with Leachy, as I mentioned. I'll go ahead and pull that up. This is just flyleachy.com. It's account driven, free account. However, so this is I'll go back a screen. So I just Googled Leachy. It's the first link. This is just the home screen, which you'll log in and you can go to your mission hub. So I'm gonna find a good area. I'll go down to our test site. So this is driven to where I'm at. So I'm in one of these buildings in here. I'm gonna go to our test site really fast. If I can find it. There we go. Okay. So I'll do a small project here, and then I'll do a slightly bigger one. That way I can show you some of the techniques for the preventing heading drift, as mentioned. A few simple ways to do that, and you're able to plan them into your mission directly. So first, I'm going to start with the settings down here, bottom left. What we can do here is we're going to set the kind of global settings for everything. We'll go through these. Okay. So units, of course, it's whatever you're more comfortable with. Heading mode, typically we use auto, so this is to next waypoint. Don't know if there's any useful applications for these other ones. Finish action, of course, we set to return to home, but of course you can use any of these if you'd like. Make sure you're on straight lines instead of curve turns, as mentioned before. So cruising speed, so we are in kilometers per hour. So about 18 to, we want to go to about 5 to 10 meters per second, so about 18 to 30 kilometers. Typically what I'll probably just honestly back this down to that max flight speed. We fly at all of ours at 5 meters per second. Anyway, so what I'll do is I'll set that to 5 meters per second. Photo capture, we're not worried about that, so that's just disabled. Default curve size, I'm gonna bump that down to 0. I know it doesn't matter since we don't have curve turns on. Pitch mode does not matter. Discover missions, that's just so you can see other people's missions on Leechy. That get uploaded. So this last option, use online elevation. So there's a kind of pseudo terrain falling that Leechy has. I wouldn't classify it as true terrain falling. What it does is it uses, I believe, some information from 3depth for the surface models, and does the terrain falling by point to point. You could maybe you can add in waypoints in between them to do a bit better on the terrain falling, but it's not true terrain falling. It's kind of just going point to point terrain falling. Works okay for most applications. There are some more true terrain falling applications out there. I've gotten mixed results for some of them. Haven't used any personally. UGCS is one that I hear about often, but haven't used personally. But if you're really needing some of those, that might just take some research into those type of flight planners. That's really all for the global settings. So generally for an area collect for LiDAR, we're going to use a predominance of east-west or north-south lines, or on some angle of the lines to cover our area. And then the one thing that we want to do is include what we call cross strip. This is more for, and I'll show you that and give you a little bit more information when I do it. It's really what it's for is it gives us some risk mitigation for calibration issues or so forth. So, and we can check the geometric fit of our data and so forth. I'll talk a little bit more about that when I get in here. So what I'm gonna do, I'll go in here, plan a mission. All I have to do is left click to drop my points. Oh, it looks like it got a point far away. Let me go delete that. So what I'll do is I'll just lay out a general plan. Typically what I'll do is I'll just lay out the general pattern and go back in and adjust the settings when I finish. And I'll put my cross strip in here. Typically you want your cross strip, if it is nice if you have buildings, to go over those, because you've got these pitch angles and you can see the values better there. So what I'll do from here, since I've got this general layout, I'm going to be flying, I'll say, let's see. Oops. I'll use one of the general purpose flights. I'll use 60-meter flying height, which makes with 25% side lap, so that makes my line spacing 75 meters. So what I'll go in here now, after I kind of got this general layout, is I can, which is probably hard to see on the webinar itself, but I'll jump this number up to 75, so that's our line spacing. And on this side, I'll just try and eyeball a straight line. You are able to experimented with it briefly with creating like a shapefile with the flight plan, and you can get a more accurate values for this, and you can import it. I haven't done too much on that, but I have experimented with just a little. I'll kind of get this straight. Drop that down. Just to say 75 meters. That's close. Kind of straighten that up. And then this last line is just this is my cross strip. So you just want this perpendicular to your other flight lines. If you have a building that you can fly over, it's nice, but if not, it's not completely necessary. I'll leave that line spacing like that because it's too big of a deal. Okay, so this is a kind of a general layout of a plane. This is kind of what a typical, at least what our test flights would look like. What I can do here now is if I select my first point and hold control and click my last point, so left click on both those, you'll see that this light, this area comes up and you can select them all. You notice all the points are green now. So I can change my altitude. I set 60 meters, so I'll use 60 meters. So you see this this section here. This is where that kind of pseudo terrain following comes in. If I click above ground, I'll also use my cruising speed because I set that in my general settings to 18 kilometers, which is 5 meters per second. All these other camera stuff, so you don't have to touch those. I'll click apply. Now if I go in here, I can look. I don't know how well it'll come up, but there's two values here now, one in yellow and one in white. So the one in yellow is my height above ground, and then the one in white is the actual value above the ground at that point. So it kind of does, and what it really does is it kind of goes gradual up to that point. So say I'm going from 3 to 4, it'll gradually go up to that height. You may want to add a couple points in between to do more of a true terrain following, but it's just an option for this. So this is kind of a general plan. What you can also do, a couple other plans. What we'll start with is I'll look at a corridor flight. I think I have one here. Let me see.
Oh, pretty good. Yeah, it's one of the newer drones and one of our sensors. So
That's not a great one.
better than the what said again? Yeah, it's a Watts Prism. It's a new like US.
Let me see. I'll just go back and just do a plan one really quick. So depending on the type of flight you're doing, so what we're trying to, with this heading drift that I mentioned, and what I'll do is I'll put this slide back up on the screen real quick and use this flight. So we're planning, kind of trying to plan our, oh, it swapped slides on me. Let's go. Okay. So what we're gonna try to do, we're trying to limit our flight line length to 500 meters. The reason being, this is kind of a word from Planix, which is the manufacturer of our positioning system. We're trying to avoid long, straight flights that are, over 500 meters because this can introduce some heading drift, and there's a few ways to plan around this depending on your type of mission. You can plan it like this, where it has, instead of doing this full flight line, we'll cut it in half and just do a plan up and then plan back down. You can also, if you prefer and you want to fly just that one straight line, you can kind of do it like this. So this is more for corridor, but can be used in almost any plan. So what we're doing is we'll flying point 1 all the way over to point 5, and we can see that these two links are 500 meters. We want to introduce some heading change. And the way we do that is if we'll fly to point 1 to point 2, we'll do a 90-degree turn to point 3, and then go back on track on our line and then continue on. So this will introduce some heading change. This is going to be similar to our heading alignment, which I'll talk a little bit more about here shortly. But I can show you this. I'll show you both methods just to give you an idea. Say you want to, let me see how far this, get rid of all my points real quick. You see how far this is. Yeah, so we got a pretty long distance here. So what I can do is if I want to fly this area, I can break it up into 2 sections. I'll just do this roughly. I won't do the line spacing, but I can fly that in 2 sections. Something like this. And then I can go, actually probably be better to say I want to use this full line, and I'll actually introduce both ideas in here. It'd be best to do it like this, then fly to this point, go 90 degrees off, go back on track, and then I can continue on with my flight and doing the same, kind of the same pattern here. Of course, you'll of course want to pay a little more attention, put these lines a little closer, but there's ways to get around that heading drift issue. I believe I have another one I can show here. That gives you a slightly better, this one maybe. This is more of a simple plan. So once you're done with say you're done with your flight plan, all I would have to do is I can go into my mission here and save it. I can also, of course, import missions, export them as a CSV. I can also, what's pretty neat and what will look more, what I can show you more on, like what I would use this for though, like that terrain following, is if I go to this flight here. Looks fairly normal here, but if you look on these values, our 60 meters up here is 75.6. Actually, it's better over here. So our 60 meters up here is 71.3 meters above the ground. But if I look over here, or above our start point, that's relative to our start point. But our 60 meters over here is 22.5, because it's a very gradual, very deep slope right there. And what I find is good to visualize this is you can actually export this to 3D KML. And this is kind of what I would use this setting for, because you can see that there's a pretty drastic drop off here that could use that terrain falling. Fairly straightforward with mission planning, nothing too special. Of course, all you're wanting to worry about is your line spacing, your flying height, and if you can do a cross strip, it is useful, especially if you have a building in the area. But if you don't, just a cross strip in general will help. Usually we don't have any calibration issues, but this kind of saves it if you do have an issue. We can fix it. Any questions on this flight planning? It's fairly straightforward. You can apply this to pretty much any flight planning. The only reason we show Lychee is because it's got a web interface for it. Yes, so Lychee does work with terrain following with the M300. The caveat with M300 is you have to use an external Android tablet hooked up to it to utilize Lychee. For some reason, they don't allow you to load Lychee onto the built-in tablet. So you have to use a separate, and only at the moment Android tablets work, or Android phones that have Lychee downloaded on there. You just plug it up. What it'll do is the tablet on the controller won't control the drone anymore. That tablet that you have hooked up will. So it'll recognize it, and it'll act just like a normal flight. But yeah, you can use terrain following with the M300 like that. You also, with this, there is, like I mentioned, there is an app, and on there you can plan just like any of these other, DJI Pilot, GS Pro, any of those where you can use the tablet. You can plan straight from there. I find planning on the computer slightly more accurate, a little easier, but I don't mind using it on the tablet either. So just easier to show. Okay. So now we're going to move on to flight operations, kind of get into what